Hello everyone, welcome back. In this video, I'll be taking you through some algebra properties of propositions. So there are some properties guiding propositions just like your own number. Recall your proposition has connectives and we have five of them: the negation, conjunction, disjunction, the implication and by implication. So, and since this conjunction are used to join two logical statements together, I mean, they are logical operator, they are used to join two propositions together, then definitely it also has some what certain properties. So, one of the properties is suppose I have if P, Q, and R are if P, Q, and R are arbitrary propositions. So when you have three propositions like this, then we should be able to prove the following by constructing our, truth table. So then the following odds, I think I've made mention of some of them in the previous video. Number one is commutativity properties. Commutativity property. Recall when we say something is commutative, that is when you change the order of the numbers involved in an operator, in an operation, and your results still remain the same. So for example, now if I have 2 plus 3, so you know 2 plus 3 is the same thing as 3 plus 2, then we say addition is commutative, because when I interact the position of 2 and 3, I still have the same result. Okay, now what of 2 minus 3 is negative commutative. You can see that 2 minus 3 is not equal to what? 3 minus 2. So, but for proposition, it satisfies commutative properties. So that is when you have your what? When you have a proposition P and proposition Q, then the same thing as what? Proposition Q and P. I hope you understand now. We can prove that. Can we quickly do this? So, but before doing that, let me give you the second one so that you do that on yourself. So, likewise, when you have it holds for disjunction too. It means disjunction of a proposition is commutative. So, P or Q is also the same thing as what? Q or P. Okay, now let me show one of them. Suppose the first one I have P, Q, and I want to find what? P and Q, Q and P. Recall that when you have two propositions, then the possible truth values you can have are what? Are 4. So then this one here, you are going to have true, true, false, false. Don't forget true, false, true, false. If you've forgotten how to obtain this, refer to my previous videos on logic. So now for P and Q, recall if you have and as your connective, that is, you have a conjunction as the connective, so then you are going to have the results of the what? Of the conjunction of the operator or of the operation to be what? To be true if both of the what? Proposition is true. So it means true and true here is true. Otherwise, it's going to be false. Then it's going to be false, false, false. I hope you understand. Now let us do it for Q and P now. It means your first element here will now be Q. So then T and T is going to give you T. False and T, that is false. True and false, false, false. So if you check them very well, you will see that this guy and this guy, they are the same. I hope you understand that. So then you can see clearly that what? So your P and Q is equal to what? Q and P, which means what? Conjunction is commutative and is what? Is commutative under proposition. So I advise you to do that for what? You can show for that of disjunction. It is not difficult to do. Just find your P, or maybe we can quickly do it. Let us just find your P or Q. Recall all of them is going to be true except false false. So it means it's going to be what? False. This is going to be true, true, true. Okay, now can you find Q or P? So Q or P, all of them is going to be what? True except false, false. So that is false. This is going to be true, true, true. Can you see it is the same? So P or Q is equal to P or Q. Q or P. So if that is clear, that's the first property. So the second properties, so is what we call associativity property. Associative property. So that is when you are talking about associative properties, then we are talking about three what? Three propositions. That is when you have that your P or Q or R, then it's also the same thing as what? You compare these first and two elements together, second element together. So you are going to have that. That is true for what? So that is true for disjunction. So it is also true for conjunction. Conjunction. So that is P and Q and R is equal to what? P and Q and R. So you can do this. I've shown this in what in the previous video. You can refer to it, or I leave this as an exercise for you. So you have P, Q, R. It means you are going to have eight possible what? Eight possible eh? Eight possible truth values. That is true, 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 true. False, 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 true, false. Go and check how I've done that. So another property is distributive property. Indeed, so your conjunction is distributive over disjunction. When you say something is distributive over something, let me write the property first. Distributive properties. So number one is that when I have what? P and Q or R is same thing as what? P and Q or P and R. You can see it means your union and what disjunction, likewise conjunction and intersection are more or less the same thing. On set, we also see that these properties are satisfied. Likewise, your disjunction is what? Is distributive over what? Over conjunction. That is P or Q and what? P or R. So you can show this. So likewise is what? The next one is it's also satisfied De Morgan's law. When we say De Morgan's law, De Morgan's law is the Morgan's property is the law that connects your negation, your conjunction, your disjunction and conjunction together. That is, when you have the negation of disjunction of two properties, then it's the same thing as what? Conjunction of their negations. I think I've shown this in the last video. So then number two, when you have the negation of what? Of conjunction of two statements, it's the same thing as what? Disjunction of their negation. Let me show one of them, then you can quickly do the rest yourself. Okay, now look at this. For the first one, let's say we want to show it. Then we have P, we have Q. Since I want to show the negation of P, negation of disjunction of P and Q, then you can have what? P or Q. After that, you can have negation of P or Q. Then you can have negation of P, negation of Q. Then after that, negation of P and negation of Q. Okay, let us show that. So you have something of this nature, something of this nature. You draw it. So at the end of the day, what we want to show is that this guy must be equal to this guy. Okay, now let us check that. Don't forget, since you have you have two statements, then I'm going to have four possible truth values. Then it's going to be true, true, false, false, true, false, true, false. So P or Q. So all of them is going to be what? The combination, the disjunction of two proposition is going to be what? All possible combination is going to be true except when they are false, false. Then it is true, true, true. Refer to my previous video. And negation of this is going to be false, 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 true. What is negation of P? That is false, false, true, true. What is negation of Q? False, true, false, true. And what is negation of P and negation of Q? That is contradiction. When you are using the contradiction as your, when you are using conjunction, so to what? uh, to join two simple statements together, it means you have to note that they are going to be true if both of them are true, otherwise they are false. So false will be false, false true will be false, true false will be false, true true will be true. Can you see clearly now? So it means that this guy as well as this guy is the same. So I want you to check it for the second one. So that's some of the properties of proposition, algebra's properties of proposition. So if you understand this video, please don't forget to like, share, and subscribe. So I will see you in the next video. Thank you.